Here we're looking at the parallelograms diagonals. And when we draw a diagonal, we're simply drawing a segment that connects the opposite corners, that connects those opposite angles, all right? That's a diagonal. And we draw diagonals with lots of different shapes. But the special thing about parallelograms is that the diagonals will actually bisect each other, all right? So as we draw these diagonals, they will cut each of each other in half. So one diagonal bisects the other diagonal and vice versa. And so when we look at something like this, it says find the missing values. So here, once again, we have a parallelogram. Since the opposite sides are parallel, we know this thing is a parallelogram. But now because it's a parallelogram, it means that those diagonals, so diagonal AC and diagonal BD, they bisect one another. And what that means is this. It means that, okay, so AC right here is going to bisect BD. Okay, so that diagonal bisects the other diagonal. And so when we look at that, if BD is being bisected, being split into two equal pieces, if I see that ED is 6 inches, well, that means that BE must also be 6 inches. Okay, and so I might ask questions like this. I might say, hey, what is the measurement of BE? And you would immediately say, hey, that's 6 inches. Or maybe I'd say, what's the measurement of the entire diagonal of BD? And we could easily say, well, that's 12 inches by kind of using segment addition to add up and find the pieces, okay? Likewise, if I look at this from the other perspective, if I say, hey, let me say that I'm drawing BD, so let me highlight BD this time, so that when I draw it, bisects the other diagonal. It bisects AC, which means if I have something like AE at 10, since I know AC is being bisected, being split into two equal pieces, I know that this piece over here, the EC or the CE, is also 10 inches, okay? And so once again, there's two questions here that I can actually answer. I could say that, hey, CE is 10 inches because I know it's being bisected, so each of those pieces is the same. But now I also know the entire diagonal. I know the entire diagonal of AC is 20 inches through segment addition, okay? And likewise, if I had the entire diagonal and said, hey, AC is 20 inches, as soon as I draw BD, knowing that that bisects it, I can find those smaller pieces of 10 inches each, okay? So again, that's the special property here. The diagonals bisect each other. So if I look at one diagonal, I say, hey, it bisects the other one. If I look at the other diagonal, I say, hey, this bisects the other diagonal, okay?